In this video, we're going to take a look at factoring quadratic equations. We want to start by talking about what a quadratic equation is, or makes it a quadratic. Here we have an example of a quadratic equation that's in standard form. Standard form is ax squared plus bx plus c equals 0. You'll notice that on your variable, the highest exponent you have is a variable of 2. That's what's going to make this a quadratic. You also have the variable x with an exponent of 1 that's understood to be there, but it's not the highest. So if your highest exponent on your variable is a 2, you have a quadratic equation. This is also an equation because it has an equal sign. You can use these same techniques we're going to talk about for factoring if you just have an expression and you don't have an equation with the equal sign. You just wouldn't be able to finish it by solving it. There's two main things that we want to take a look at in factoring quadratic equations. We said it's set up as ax squared plus bx plus c. Well, the a, b, and c represent numerical values that are in your equation. It makes a big difference if that first value, a, is equal to 1 or it's a different value. So I've given you two examples that we'll take a look at. The first one is a equals 1. Here's our example of a quadratic. X squared minus 3x minus 10 equals 0. And we'll look at factoring this one in just a moment. But if a does not equal 1, you might see a quadratic equation that looks like this. 2x squared plus 11x plus 12 equals 0. It's easier to factor them if x equals 1. Often you're going to see that on the GRE. Well, they'll have a lot of them where maybe just the x squared term is by itself without any coefficient or number part in front. But you may run across a few or set them up in some word problems where you do have a value in front of the x squared. So let's take a look first at how to solve things when you are using factoring if a equals 1. For people who like steps, I've listed some steps. The first thing you want to do is make sure you set your equation equal to 0. Look for two factors of c, that's this value, that add to give you the value b, the one in the middle. Then we'll use reverse FOIL to write our factors and set each factor equal to 0 and solve it. So for example, I'm looking for two factors of this value negative 10. Always make sure you take the sign that's in front of your number. I could list different factors that I have for negative 10. I might try 5 and negative 2. But realize that you might have the negative with the other term. So I also want to check 5 as being negative and positive 2. We also have factors of 10 and 1. So 10 and negative 1, or negative 10 and positive 1. You can list all the factors, or you can go as far as you need to until you notice that two of the factors sets that you have are going to give you that middle term. And we have that occurring right here. Negative 5 and 2. Negative 5 times 2 gives me the negative 10, and negative 5 plus 2 gives me the negative 3. So negative 5 and 2 are going to be those values I want to use to write this with factors. I'll go ahead and set up my factors. X minus 5 for the negative 5, and x plus 2 for the positive 2. Once you have each of your factors, if they're supposed to multiply together and give you 0, that means either x minus 5 equals 0, and x equals 5, or x plus 2 equals 0, and x equals negative 2. Now notice you will get two solutions for quadratics. That exponent that we talked about as the power that you had that makes it a quadratic also is telling you how many solutions you have. So for all your quadratics, you will get two solutions. Here we have several others that we can look at to try to factor. So we just want to run through a few so that you get the idea of what you'll want to work on. Remember, our first step was to set it equal to 0. And you'll notice that this one is not set equal to 0. I'm going to need to move the other term over first so that it is equal to 0. I'll have x squared plus 11x plus 10 equals 0. Now go ahead and use that same technique. List some factors that you have for 10 that multiply together to give you that value, or add together that give you the value for the b term, positive 11. This time I notice that the factors I'm looking for are 10 and 1. 10 times 1 is 10. 10 plus 1 is 11. So a positive 10 and a positive 1 are the factors I want. Again, once you have it factored and set equal to 0, take each of your factors and set them equal to 0 and go ahead and solve it. X plus 10 equals 0, so x equals negative 10. Or x plus 1 equals 0 and x equals negative 1. Again, you will end up with two solutions for your quadratic. When you look at the next one, again, you're going to notice, hey, I have an x squared term. It's got a value of 1 in front, so I'm going to use this same technique. But it's not set equal to 0. So again, you'll want to move that 16x over so that it's set equal to 0. I'll have x squared. I'll subtract the 16x from both sides. Plus 48 equals 0. Sometimes with larger values, it's going to be harder to find the ones that you're looking for. Again, remember, you're trying to find two things that multiply together to give you 48 and add together to give you negative 16. Be careful with the signs. You can kind of tell, since this is a negative number, I'm going to have two values that are negative when I look for my factors. If I multiply two negatives together, I'll get a positive value for the positive 48. But if I add the two values together and they're negative, I'll end up with a negative in the middle for the negative 16. So if I'm looking for some values for 48, you might come up with all kinds. 48 and 1, 24 and 2, 12 and 4. You're going to keep going until you find two factors that multiply together to give you that 48 and add together to give you the negative 16. Looks like this time we found negative 12 and negative 4. So for our factors, we'll be using x minus 12 and x minus 4. Again, set each of your factors equal to 0. So x would equal positive 12, or x would equal positive 4. Notice that the solution that you get is different from your factors. My solution here was a positive 12 and a positive 4. But the factors that I had were negative 12 and negative 4. The signs are always going to be the opposite, whether you're working with the things that are factors or whether you're working with the things that are solutions. The last one I want to look at is a little different because you'll notice it doesn't have necessarily all the same terms. You have the x squared term and the x term, but there's no constant term at the end. In this case, I can still use that idea, but I'm not going to have it a little different. I'm going to look for something they have in common and factor it out. So you're using your distributive property in reverse. I'll notice they both have an x, so I'll pull an x out front, and that will leave me with the group x plus 5. Again, you can check it by using your distributive property. See if you come up with the same thing you started with. These really are two different factors. You have this as one factor and this group as your other factor. Even though it's not in the parentheses like we usually see it, you still have x being a factor, so set it equal to 0, or x plus 5 as your other factor, set equal to 0. And you can solve it. X equals negative 5. You do still have those two solutions. One of them happens to be x equals 0. The other one, x equals negative 5. Working with ones that have a value of 1 in front of the x squared term is easier. But sometimes you're going to end up with values in front of the x squared term that are not 1. So we want to take a look at some steps that we can use in order to solve these using factoring. We'll start the same way. You want to set your equation equal to 0. Here's where it's a little different. Now I want to look for two factors of a times c that add to b. It's different than what we looked at before, just factors of c. I'm also not going to use those two numbers as my two factors. Instead, I need to rewrite the x term using these values. That's going to give me 4 different terms. And when you use your FOIL, usually first, outside, inside, last, you get 4 terms. That's what we're doing. We're working backwards for the FOIL. so that we're coming up with what the first, outside, inside, and last terms were before they were combined. We'll use what's called the grouping method to go ahead and find the factors, and I'll show you that in an example. And then again, we'll set each factor equal to 0 and solve it. So here's the one that we looked at earlier as our example that was set up where it does not have a value of 1 in front of the x squared. We've got 2x squared plus 11x plus 12 equals 0. It's already set equal to 0. So what I'm going to do is I want to multiply the a term and the c term together. 2 times 12 is 24. I'm looking for factors of 24. This time, I want those factors to add and give me positive 11. So you can start listing any factors that you can for 24. 12 and 2, 6 and 4, 8 and 3. Keep going until you find two values that are going to add together to give you 11x. I found them, 8 and 3. 8 times 3 is 24. 8 plus 3 is 11. The idea, though, is this time I'm going to rewrite that x term in the middle. I want to split it apart so that I have 8x and 3x. So you'll notice I've rewritten that middle term. Instead of being combined, this is what it was when you did the FOIL before you combined them. Now here's the grouping method I wanted to talk about. You want to take a look at your terms and do them in groups of 2. I want to look at these first 2, and then I'm going to look at these last 2. I want to see what they have in common. So I'll notice from the first ones, they both have a factor of 2 and a factor of x. Let's go ahead and pull that 2x out front, like we did in our last example where we used the distributive property in reverse. I'm going to have left a value of x plus 4. I want to do the same thing with my next set. I've got 3x and 12. They both have a factor of positive 3. So I'll put down positive 3. I factor it out with my distributive property in reverse. I'm going to be left with an x plus 4. The thing you want to note is that you have the same group of x plus 4 in both. If you don't end up with the same group in both, you're not going to be able to use the grouping method. That's what's required. Once you notice that x plus 4 is a common value for both, that's one of your factors, x plus 4. The other factor you're going to get from the 2x and the plus 3, the values that are in front. So this is how you can use your grouping method. X plus 4 is that common factor that they both have, and the 2x plus 3 becomes your other factor. Again, to finish it, you're going to want to set each factor equal to 0 and go ahead and solve it. So I can take x plus 4 equals 0, and x would equal negative 4. Or 2x plus 3 would equal 0. Subtract 3 and divide by 2. X equals negative 3 halves. Again, because it's a quadratic, you've got two solutions. These take a little more work. You can go ahead and actually solve these just by using trial and error. But the grouping method always will work, and sometimes if you have a set method to use, it's a little bit faster and easier and more efficient, especially under the time pressures that you have for the GRE, knowing exactly what to go through and the steps to use in order to solve it instead of just guessing and checking. Here's two others that we can look at that also have the a value not equal to 1. Now remember, when you want to go to factor these, you want to start by multiplying the a term and the c term. I have 3 times negative 8, negative 24. I want to list all my factors of negative 24. Remember, one will be positive and one will be negative. We had 8 and 3 last time, so let's try those again. If I add 8 and negative 3, I'm not going to get negative 10. Also remember that you have to switch the negative sign. So negative 8 and positive 3. Again, I'm not getting negative 10. But I do notice I probably want the bigger number to be negative. I need two factors that are going to add to negative 10. Well, 12 and 2 will give me 24. So negative 12 times positive 2 is negative 24. And negative 12 and positive 2 will give me the negative 10 in the middle. These are the ones I'm going to want to use, but not as factors, but as a way to rewrite my middle term, that x value. 3x squared minus 12x plus 2x minus 8 equals 0. We've broken down that negative 10x and put down the two terms it had before they were combined. Use that grouping method again. Take out what you see in the first two that they have in common, a 3x. We're left with an x minus 4. And take out what these have in common, a positive 2. Again, we're left with the x minus 4. That x minus 4 is a common group, so that is one of your factors. Your other factor will come from the 3x and the plus 2. Finish solving it by taking each factor and setting them equal to 0. X minus 4 equals 0. So x equals 4. And 3x plus 2 equals 0. 3x will equal negative 2, and x is going to be negative 2/3. Again, you've got two solutions for your quadratic. The ones we've taken a look at the beginning have all been set equal to 0. The last one that you're going to notice is not set equal to 0. So the first thing I'm going to want to do is move the 6 over so that it is. I'll have 5x squared minus 7x minus 6. Again, we still want to look for the a times c, 5 times negative 6 or negative 30, factors for this that add to negative 7. Again, I'm going to need one positive value and one negative value. Anything that ends in 0, 10 is always a factor, so that's an easy one to try. I might try negative 10 and 3 or 10 and negative 3. Since I need a negative 7 in the middle, it looks like this is the one that's going to work, negative 10 and positive 3. So rewrite that x term using those. 5x squared minus 10x plus 3x minus 6 equals 0. Take a look at your first two. Pull out anything they have in common. I'll factor out a 5x, and it leaves me with an x minus 2. And do the same thing for your next two. This one I'll factor out a positive 3, and it'll leave me with an x minus 2. Again, that x minus 2 is a common factor for both, so that's one of your factors. Your other factor is going to be made up from the 5x and the plus 3. Take each factor and set it equal to 0. X equals 2, or 5x plus 3 equals 0. 5x will equal negative 3, or x is negative 3/5. Again, you do have those two solutions because you are working with your quadratic. Now, we've talked about how to solve quadratic equations by using factoring, and we've gone through the process several times. So if you have one that has a value of 1 in front of the x squared, it's easier to factor. But if you don't and you have a number in front of the x squared term, you can still factor it, but you'll want to use the grouping method. What if you can't factor the quadratic? I want to show you an example of what I mean. So I've got one that's an x squared and one that is a 2x squared. It's got a number in front. I'll start out the same way I normally would. I want to set each of these equal to 0. So I'm going to go ahead and move everything over so that I have x squared minus 4x minus 7 equals 0. I'm going to again look for factors of 7, negative 7, because this is an x squared term. The only factors that you have for negative 7 are negative 7 and 1 or 7 and negative 1. 7 is a prime number, that's it. And if I add these together, the first set gives me negative 6, the next set gives me positive 6, none of them give me a negative 4. If you list all the possibilities and none of them work, you know this one can't be factored. Now that doesn't mean we can't solve it, but we can't factor it to solve it. Take a look at the next one. The same idea. I've got a 2x squared and a negative 6. A times c will give me negative 12. So I want to list factors for negative 12. I have negative 12 and 1 or 12 and negative 1. Neither of these add to give me a positive 3. Let's list all of our factors for 12. We've got negative 6 and 2 or 6 and negative 2. Here I get 4 and negative 4. Let's try 3 and 4. Negative 3 and 4 or 3 and negative 4. Now I have a 1 or a negative 1. These are all the factors that you have for negative 12. We've tried them with positive and negative signs in front of each, but there's no combination that's going to give me a 3 in the middle. So again, that's how I know this is one that can't be factored. Even though you can't factor it, you may still be able to solve it. And what you'll want to use in order to solve these would be the quadratic formula. That's another lesson.